Hello, my dear friends. This video is ethers, alcohols, phenols, and ethers have a chapter. The ether ki part to revision. Explain to again. Now, ethers say R O R dash na equina represent the R C and the R dash say alkyl natragana aryl group. I don't know kaweba. R dash kasi manabayai, manadabayai, manaragana equina kakoba. Symmetrical ether, manadragana unsymmetrical ether. Ko say I. Now, the example say the hand with the ko C R ki jagah and R dash ki jagah na CH3 lawre anima ko. The magi IUPAC nomenclature se mit ikhoina alkoxy alkane na high IUPAC nomenclature se ki part se IUPAC nomenclature ki khatani ko. Alkoxy alkane na high alkoxy part se RO duni RO part se ikhoina kamai toba carbon masing hanthana yawdo adugi part to in low web ko aduga alkane part sina larger alkane larger carbon masing yawb the for example sida CH3 ni methoxy methane har som nakan gi se methoxy aduga sigi sina kai methane na high rob maram di carbon masing manare ba ko adu sidai the fig example sida hojik CH3 CH2O CH3 ne ba ko sidai da carbon masing handaban nakan si som nakan si oret na ko and so this part will be our alkoxy part so this is methoxy and ethane part na carbon masing yamba ethane ko the alkane part na carbon masing yamba CH2 CH3 si oret na ko so its IUPAC nomenclature will be methoxy ethane common name the dimethyl ether habiyai ethyl methyl ether habiyai yare ko mathang da sigi keno si lawre ekhona ko carbon yamba si carbon ahum gi chain se main chain ne lawre 1 2 3 aduga ethoxy carbon da tapa 2 da tabe ko aduna magi maming si 2 ethoxy propane say this is another example say they suppose si ethoxy part le ko aduga ethoxy part si carbon ahum gi ahan ba carbon da tabe aduna mai maming si kariyen ko ne ba 1 ethoxy propane in hydrogen ne ko now cyclic matang da khara benzene da OCH3 tap se any sol ka win natragana methoxy benzene habi hai OCH3 OCH2 CH3 tap ne ethoxy benzene harani ko ado OCH3 tabe nitro su tabe dorgadi say the 1 piraga 2 piraga 3 piraga 4 piraga mari suba carbon atom da kana tabe nitro tabe so the IUPAC nomenclature of this compound will be 4 nitro any sol ya ine ko lude ko ado sida da mathangi ke no de ngo oi chama tapsale aina ko oi chama tapsale ethoxy group tabe now alkoxy or ether gane alcohol ga priority order the alcohol na priority wang be hele aduna oi stop carbon atom do adu dai dai ko no 1 and piraga 1 2 3 4 ko for the ethoxy tabe ko adu phenol ni benzene do oi stop si phenol ko so magi IUPAC nomenclature si kai ko re for ethoxy phenol two more examples say pire ko say the OCH3 le re aduga COCH3 OCH3 tapana methoxy benzene any sol kaure aduga COCH3 tapasi yaw dabida adu ikona acetophenone kawi adu ketone and the ether ni again ketone has higher priority over alkoxy group so sidai the 1 period 2 period 3 period 4 period double bond natte ko say numbering gi 1 ni ko aduna 4 da kai tabe methoxy tabe 4 methoxy acetophenone yare ko last da IUPAC nomenclature ki ko say IUPAC nomenclature ki part ni ko IUPAC name se ni re adu sai de ether ma aina lawre aduga kedoba cyclic chain ma say the e re na ko the OCH2 CH3 ni propoxy ko wi ko say propoxy and the sigi carbon sigi chain da han bas dai na kai 1 se period se the 2 period nitro tabe second carbon atom da kai tabe nitro first carbon atom da kai tabe propoxy so nitro ga propoxy ke se nitro se my priority ma su leitawni adu sisu priority leite mayam na name ba functional group ngakta ni alkoxy ka na ga nitro ga se so sugumba ni yaur ko matam da ikhoina alphabetical order the priority p ko propoxy starts with p nitro starts with n so say the 1 p ko 1 propoxy 2 nitro then this is cyclohexane so these are some examples of IUPAC. Okay, now let us start preparation of ethers. Ether ki preparation ani ni ko Williamson synthesis haiba maga aduga dehydration of kana alcohol haiba maga at 413 Kelvin da ko ahan basi Williamson synthesis ni. In Williamson synthesis we take an alkyl halide which must be a primary or secondary. Now if what will happen if we take a tertiary haloalkane, then that is also given in the examples, but this has to be for the preparation of ether, the alkyl halide has to be a primary or secondary. Okay, so this is our alkoxy part, sodium alkoxide. RO minus will be our nucleophile. This is SN reaction actually. Sigi RO minus attacks this carbon atom as nucleophile to displace this Cl. So we get our ether RO, R. Or you can say this is suppose this is R dash, then this is our R dash. OR se OR sina Cl की जगह लाऊँगी ether ने को यारे को. Now this reaction is called Williamson synthesis. Let us take some example. First example is methyl chloride लाऊँगे कोई न को. Methyl chloride का करना का reaction तो ले sodium ethoxide का reaction तो ले. This is minus, this is plus. So this ethoxide minus attacks this carbon atom as nucleophile to displace this Cl. तो CH3 की जगह तक नाला नि O दकी समकदमी को सुमाइना OCH2 CH3 है ना. This is our CH3 is here. Instead of this Cl, this ethoxide group comes over here plus NaCl. I have not written the byproduct. Okay. Now सीधा I sodium phenoxide लाऊँगे methyl chloride का को. Now methyl chloride का sodium phenoxide के लोग मतलब जैसे कि phenoxide ion से this acts as what? This acts as nucleophile to attack this methyl group as nucleophile to displace this Cl. So we will get benzene O will be attached to this methyl group to form NaCl. Okay, plus NaCl again. Now what happens if we combine chlorobenzene here instead of methyl? If benzene comes chlorobenzene and here sodium methoxide का sodium methoxide का chlorobenzene का reaction तो रहती, what will happen? Suppose I am saying this instead of this sodium phenoxide, if I take this as CH3ONA सिलो रे बको CH3ONA अदुगा सिगी methyl chloride सिगी जगह दना ने I सुमाइनो इन लो रे बस सिका इनो sodium phenoxide ने बको. What will happen? No. Sisi chumi brain to isbo. Sisi low is right. Sidai the kai low bahaba. Cl low bahaba. Chlorobenzene ka naga sodium phenoxide ka. Ado sidai the sigis nucleophile sina ne. Methoxide ion se sina. Benzene ringi si carbon atoms. The nucleophile on attack toba is very difficult. So literally there will be no reaction of sodium methoxide and chlorobenzene. So sigani sigma reaction tho oi have ko chlorobenzene da or halorine da nucleophile am attack to is very difficult because of there are four reasons. Ahan bada ama khatang hairage carbon double bond laibana maram ogana pi bond laibana maram oraga there is excess of electrons in benzene ring, so it is very difficult for the nucleophile which also has excess of electron. Electron excess level benzene da electron excess level nucleophile na take toropa and isi ki marakta kai thokani repulsion thokane. So there will be no reaction. But there can be reaction, but that is very difficult. Okay. Now let us move further. Ahum sub example dane if I take a tertiary halide anga sa hagi bido tertiary halide lauroi dabni habido laure ba reaction tho oi habidina te thokane ba but ether gi formation tauroi CH3C CH3Cl CH3 this is a tertiary halide. Okay, tertiary halide siga CH3ONA ga reaction to haleba CH3ONA sina kamai to ba sigizina nucleophile ona attack to ba gi mahutta ne sigizina. In fact what happens is suppose this is our CH2H. Okay, CH3O minus ion sina ne. Let me rough this one. CH3O minus sina sigi hydrogen sibu abstract to guneba S kari oina base on abstract taweba base on abstract tawraga sigi hydrogen sigi electron ani si magda kari bond semba double bond pi bond nama same ganeba aduga sigi Cl se thokhrane sigi Cl si thoga di kai form tawrne duda CH3C CH2 gi marakta kai rani double bond nama silait aduga Cl sima thokre ko aduga CH3 habidi alkene की formation तवेबा alkene की formation तवे as the major product if we take a tertiary halide now further example सेदा आई मथंग पीरे CH3Cl का कनागा tertiary दुना ने सोंगी पार्ट से इकोन tertiary alkyl group यावबा को tertiary alkyl group यावबा ether की formation तवहन के हायरगदी इकोइना alkoxide group अदु tertiary alkyl group तो करमदा alkoxide group तो अदुदै यावहन गदबा halide की part दा alkoxide tertiary part यावहल रदी elimination reaction takes place instead of nucleophilic substitution reaction to form this alkene so aduna koina tertiary alkyl group yawa ether ma form tawhan ge hairagadi tertiary की part to alkoxide group to यावहल लगदी the reaction easily occurs sumaina sigi o se tertiary butoxide haiduna kawi ko sigi tertiary butoxide sina sigi CH3 sida as nucleophile ona as kari ona nucleophile ona ko SN2 ni this is SN2 reaction ne ko si attack tawrani aduga sigi se soin thoga this ether having a tertiary alkyl group is formed IUPAC nomenclature of this compound will be 1 sedulare sed 2 lerani sed kari lerani 3 ani suba carbon atom da methyl tabe ani suba carbon atom da kari methoxy tabe the methyl ga methoxy ga se methoxy na hali 2 methoxy 2 methyl propane these are some reactions of Williamson synthesis adu ahum so parts na reaction budi Williamson oraga ether ki formation tawdeba ko alkene is formed as the major product okay in the last preparation in the second and last preparation of ether is from alcohol by dehydration when an alcohol is heated with concentrated H2SO4 at a temperature of 413 Kelvin then substitution reaction takes place to form ether ROR so this is dehydration reaction water is produced if we take as the example of ethanol when ethanol is heated with concentrated H2SO4 at 413 Kelvin then formation of ether takes place we can simplify this reaction like this is our CH3 CH2OH another molecule of same alcohol can be written like this is our another ethanol molecule one hydrogen from one ethanol molecule and OH from another ethanol molecule to form this water aduga CH3 CH2O da kana takrani CH2 CH3 takrane CH3 CH2O da CH2 CH3 sumaina ko si thokraga ether ki formation to ba yai now if we heat this alcohol with concentrated H2SO4 at a higher temperature of 443 Kelvin then elimination takes place instead of nucleophilic substitution to form this alkene as the product beta carbon dagi hydrogen ama thokani alpha dagi OH thokani water ki formation tawraga alpha and beta ki marakta double bond ki formation tawai ko ethene ki formation tawai this is also included in your syllabus okay these are some preparations of ethers now let us move to the chemical reactions of ethers chemical reactions so again ani khaktani hydrogen halide ka reaction tauba ama aduga hydrogen halide ka ko aduga magi ESR electrophilic substitution reaction now hydrogen halide se gi x se kana oiba yage hai kadane this x can be chlorine oiba ya or bromine oiba ya or iodine oiba ya fluorine oide ya de fluorine si oide se karigino hargadi fluorine gi kaidoba magi reactivity ko हाइड्रोजन फ्लोराइड की रिएक्टिविटी यामना लेस होएबा को अदुना मरम ओरगा इखोना क्लोरीन नत्रगना ब्रोमीन नत्रगना आयोडीन लवी for this reaction. Okay, so ether ka kanaga HAS ka reaction tawre, the reaction can be SN1 or SN2 depending upon the nature of the alkyl group present in this ether. Tertiary alkyl group yaurko matamda khaktani SN1 ge through the reaction thokadaba ko, tertiary yaudrakadi SN2 da dum thoe. Now sigi bond sittalle X minus na nucleophile on attack tawraga adu sayda alcohol R O dana kana H tabe R dash dana kana tabe X tabe habidi alcohol ka kana ga alkyl halide ka form tawre ko example ina yengo sidaida CH3O CH2 CH3 lawre na ko unsymmetrical ether am lawre sigi carbon som na kani carbon atom sida magi steric hindrance name ko steric hindrance name na maram oraga Br minus to na as nucleophile na attack to budu lai re ba som de attack tawre aduga adu namaram oraga sigi bond so te ane ko adu di CH3 da kana tabani sigi Br se CH3 da test tor ane ba do di methyl kari bromide form tor ne ba aduga CH3 CH2O da na sigi H sita phorga ethanol gi formation ta u bane ko yare ko ani sub example that now I am taking ethoxybenzene ethoxybenzene si laure na ko ethoxybenzene sida ICL ga reaction to le ICL ga reaction to bese som gi bond sidi resonance ki through the resonance number morga benzene ga carbon oxygen ga gi marakta carbon si ga oxygen si ga marakta double bond character am se lai ba ko sumaina say benzene ni suppose say the O CH3 lai re ko say the lone pair ni dana adu sigis da come to ba double bond sumaina lai ba so since there is a partial double bond character between oxygen and carbon bond. In this carbon and oxygen bond, this carbon and oxygen bond is very, very strong. So it is very difficult to break this bond. So instead of attacking this carbon atom, this nucleophile would easily attack this carbon atom. So this bond will be broken. O da dum aistaba ane ba ko phenol gi formation adum fix on la dam is da ko kai gumba benzene yaura ka de aduga bond sit talabni na CH3 CH2 da kana la ni nucleophile da attack tawraga chloro ethane form tawrane ba now say da tertiary kai gumba yaura magadi this is a tertiary alkyl group yaura magadi reaction undergoes through SN1 reaction. SN1 da kamay to ba step ani da thoi SN1 da ko step ani da thoi ahan ba steps da ke do ba stable over carbocation am form to ne stable over carbocation form to sikar matam da thokani now sigi bond city uraga bo si bond city aga bo sigi carbon sida positive charge la kani methyl carbocation form to methyl carbocation su stable ho gedro oi roi ko aduna maram oraga sigi bond so na take kan have ko adu tertiary carbocation form to rani now tertiary carbocation the sigi iodide ions in attack to rani as nucleophile to form this tertiary hello alkane okay aduga CH3 sidi tatla roy ba ko CH3O dana kanala ani H hapsala ani aduga methanol form to now sidi important of a point council so hangraba question ni sidi the ethoxyethane se or natra methoxyethane ogera ko sida HI ga reaction to ramba adu HI da kari harama ba excess na harama gadi excess in higher magadi come into say HI reaction to matam the Sidai the Karilakpa OH laga Sidana I lakaduri never go alcohol amaka form to Udova iodide amaka form to duri never halide amaka. But since the halide is taken in excess, Sigi OH say this will also be replaced or substituted by the nucleophile iodine to form a mixture of iodides only. Simbanabagi anise enough same laurubagi say the anisimanani 2 moles of kana iodoethane form to in high never. Now sidai the suppose I say HBRC excess in iramagadi. Then this will be bromide, okay. Sigi say ethanol ki jaga the ethyl bromide form to never. Yariko. Okay. These are some reactions of ether with hydrogen iodides. Now let us move to the last reaction of ether, that is electrophilic substitution reaction. In electrophilic substitution reaction, due to resonance, due to resonance, this OR is an ortho and para directing group due to resonance. The resonance of this, for example, say aina se low si kaino any sol to never cause sig resonance to hanma matamda say double bond lakani si pi one si car ga ortho position da kedoba electron excess o hen ganeba ortho position da ge maka double bond se maga bond si car ga para position da maka kedoba electron excess o hen ganeba ko madu resonating structure they say here okay aduna ortho and the para position da kam into ortho and the para position da sumaina electron reach o hen ganeba ko due to resonance electron reach o helabanina the electrophile would attack the position, therefore OR is an activating orthopara directing group. Yamne strongly activating the oide but activating the oiko deactivating oide have. Say for example halogens kumba ko adagi aldehyde ketone mohisi benzene ring that attached already they are electron withdrawing groups, they are deactivating groups, but ORC electron donating group ni pisalakpa group ni aduna activating group ta challeba ko. Now some examples of electrophilic substitution reaction of any salt, this is our any salt, is first the bromination daure Br2 ga in presence of FeBr3 adumagi ortho and para position da ortho da Br taphale para dana kari taphale na Br taphale sumaina ko ortho ga para isomer se ani sida para isomer the major product O generally ko in exception is there. Sida the exception like mathang the nitration, this is bromination, this is nitration. Nitration da mo kedoba concentrated HNO3 ga reaction to hola in presence of concentrated H2SO4 ka reaction to matam the electrophile ma generate to and that electrophile is NO2 plus and this NO2 plus electrophile will be substituted at para position or ortho position. Para gidu major product ko ire ortho do idre se ko. Then sulfonation, this is our sulfonation. Sulfonation to one matam the sulfonation gi koina kai doba reagents chimpa po bitare sulfonation gi reagents kaino SO3 in presence of concentrated H2SO4. Sidagi SO3H plus have electrophile generate the way CS nam S ki through the nico S ka bond same the O ganate S ki mapa the bond line ching the nico aduna any sol ke kariba O CH3 ki para position the SO3H la hai. This is 4-methoxybenzene sulfonic acid. Benzene the SO3H tap se benzene sulfonic acid ko buni aduna 4-methoxybenzene sulfonic acid. Then the last two reactions of ESR is Friedel-Crafts alkylation. This is Friedel-Crafts alkylation. Ethyl chloride in presence of AlCl3 reaction taureba ko adu magi para position da ethyl group 2 tap A aduga Friedel-Crafts acylation dana. This is our acyl chloride, acetyl chloride in presence of again AlCl3. So the electrophile CH3CO plus electrophile generate away. Adugi CO plus CH3 harinico say CH3 say si methyl group ni si form the sigi IUPAC nomenclature say 4-methoxy acetophenone hydrogen. This is our Friedel-Crafts alkylation. Sigi say makas kum the uram the yai ko I kitang say the mathakta irake sumaina silere ko sidaida sigi OCH3 se initial lere magi para position da ke doba sigi COCH3 sita be C double bond O CH3 sumaina ko sigi maming kari ka weba 4-methoxy acetophenone seta bisu CH2 CH3 niko if you cannot see O CH3 gi para position da sigi CH2 CH3 sine bata bisi ko CH2 CH3 okay sini sigi revision se kanagi ethers ki ether the question hangali maroina sigi chemical reactions of ether dane reaction with hydrogen iodide se sigi se hangali reaction mari sida ko excess ju hangrabani aduna ether gi part si pick tipi aga reaction ani chemical reaction ani khatani aduga kari preparation so ani khatani chemical reaction ani preparation so ani khatani aduna exam da khara dum toina hangan mani se ko sema yengsan biro aduga video sibu noi friends sing da club namana bi sing da video sibu share to you. And if you are new to the channel, please subscribe to the channel. Thank you.